going to do 12 through 15. We'll go over these when you guys are ready. So start with that. Okay, let's talk about these here. I didn't think they were as bad as some of the ones we did in earlier sections, but let's start with number 12 here. Let's start with Luca. We haven't heard from you today, so you want to tell us what you did with number 12? You're sure? Okay. Dylan, you want to help out there? Okay, Marcus?
I said it was dx is
Okay, tell us how you got there, Marcus.
I added 10 both sides.
Okay, added 10 on both sides. Okay.
Which gave me 2x is greater than 40.
Okay.
And then I just divided 2.
Divided 2 on both sides, so x is
Greater than 20.
Greater than 20, yeah, that's right. So best answer was D on that one. That's good. So Lily, your hands up. You want to talk about 13 then? It might be a different answer here. Let's see what happened. You want to just walk us through what you did, and maybe we can find out what happened? Okay, so you subtracted 28.
And wash up the 3 times, negative 3 times 7.
Yes. But, okay, so instead of plugging it in here, everyone, I want you to keep isolating this variable because something's going to happen here. Does anybody know what I'm talking about? You've got to flip it because look what happens here. I know you plug the 7 in here, but watch what happens here. If I divide by -3, if I divide by -3 on both sides, this cancels out because it's 1. This has to flip. This becomes 7. So L is less than 7. That's your answer. L could be which of the following. It has to be A because it's less than 7. I think you originally said B, right? So it was a little bit tricky there because if you plugged them in, it would have given you this false confidence that the answer was 7. But because we're dealing with inequalities, isolate it all the way down to when L is by itself. And then you'll see, oh, okay, it's less than 7. So the answer is A. There's a little bit of tricky part to it there. Olivia, did you get number 14?
I got A for number 14.
Okay, that's right. Let's talk about it. How'd you get there?
So I first subtracted 5 from both sides. And then I got 2D is less than 12. And then I divided both of them by 2.
You divided by 2 on both sides. Okay. So D less than 6 is the right answer. No need to flip it because there was no negatives going on here. So answer is just D is less than 6. Let's go to 15. Omar, did you get that one? Okay, or did you have a question about 14?
Yeah, I got it.
Okay, you got it? Okay. Who got to 15? Who wants to share that one? Let's go with Dylan over here. Okay, you want to tell us how you got there?
So then I subtracted and then with the lost.
Okay. You got negative x, and then you subtracted this. What'd you get? I'm just following what you said, and it's right so far. Negative 6. Now what do? You divide both sides by -1. So since you're dividing by a negative, what happens here? It switches. So this becomes, now x is greater than 6. So our best answer is D right there. Does everybody see that? This one was one of those tricky questions. When you're dividing or multiplying both sides by a negative, you got to flip it. Okay? Everybody sees that? Everyone's cool with it. Okay? We're going to move on from inequalities here, and we're going to move into geometry, which is on the next page. Any questions before we continue? Okay, forever hold your peace on this one. Okay. Let's look at this. We're going to deal with geometry and angles. How many of you guys have taken geometry already? A little bit? Some of this will be more introductory, and if we have time, we'll go a little bit deeper than this. But let's start with figure 1 here. Blanca, you want to read this one for us?
In figure 1, what is the value of x?
You want to try this one? Not really? Okay, Dylan, you want to tell us what you would do here?
Circle where all the angles is that's how much. That's the angle of the circle.
So what Dylan's telling us here is he's saying, let's draw a circle around here. And you can do that. There's nothing wrong because each of these lines basically, there's no space that's unspoken for here. That's what's going on. Keep going here. So
Since there's 5 angles, you divide 360 by 5, and plus 3 is 50. 5 goes in 36, the maximum 7 times, and and there's only one dimension of that would be 7, so that's it.
72, that's right. So each of the x values equals 72 degrees. That's right. So that's correct. Does everybody see how he did this? He basically said, since there's 5 x values, 360 divided by 5 is 72. That's correct. Okay. All right. This is some useful stuff here at the bottom of this page, and I thought this was helpful to it. It says angles that form a straight line and add up to 180 degrees are called supplementary. Okay, supplementary. So, what are two pairs of angles that add up to 180? Tula?
C and E.
C and E. Okay, a little bit of reasoning here. Tell us why C and E works. Do they form a line though? They don't have to, but what I will say is this: as long as they add up to 180. So they are supplementary because they add up to 180. But typically they're looking at things that are on the same line when they're talking about supplementary. Those do add up to 180 though, because what they're saying about C and E is actually that they're vertical angles and they're equal to each other. C happens to be 90, so E must be 90. Okay, so yes, they do add up to 180. Are there any angles on a same line that add up to 180? Do you guys see any? Look at the page. No? Take a second look. Olivia?
A and B.
A and B. They're on the same line. They add up to 180. Do you see another one, Tyler?
That C like a square on it, so that equals 90.
Yeah, but on the same line. Marcus?
I would B and C like
B and C do not. B and C do not.
C and D.
C and D do.
With B and G.
B and G do. Add up. A and H. Good. Those add up to, they're on the same line, but they create a line. But B, the one that Marcus gave us, B and C, they don't create a line together. So, because I can tell by looking at B, it's greater than 90, and C is 90, so that would add up to more than 180. So that's why B and C do not work. Does everybody understand supplementary here? Is this something you guys have learned? Yes, okay. The next one is vertical angles. This is actually what Tula brought up earlier. But C and E, they're directly across from each other. They're equal to each other. So C is 90, E is also 90. Okay. That's the same with F and D. Do you guys see that? Those are across from each other. They're opposites. So these vertical angles are often called opposite angles. And when they're opposite of each other with two intersecting lines like that, they're equal to each other. So can somebody else find some other ones? Tula?
B and H.
B and H, that works. Okay. Any others that you guys see? How about A and G? A and G are also verticals. Okay. So the key behind all this that we're talking about right now is just that you learn these terms. Because these vocabulary words from geometry, they're really just testing us to see if we understand them. Okay. The next one is called perpendicular. How many of you guys have heard the word perpendicular? Okay. What does it mean, Tyler?
It's like basic.
Not always. Well, yes, they are, but a little bit tricky. Yeah, that's true, but that's not how they usually define perpendicular. What's that, Omar? It's any. It doesn't have to be basic height, is what I'm saying. It can be, but it doesn't have to be. So let me just show you something real quick. Any two lines doesn't have to be in. Like when you think of base and height, you're thinking of a shape like a triangle or a square. It doesn't need to be in a shape. It could be just two lines like this. That's perpendicular. Two intersecting lines or two lines that meet at a T like this, that's perpendicular also. So it doesn't have to be inside of a shape. Does everybody see what I'm saying? Yeah, what Tyler brought up is true. He said, well, you're talking about a triangle. Here's your height, here's your base. Yes, that is 90 degrees. True.
Oh, it's gonna be 90 degrees.
If it's perpendicular. This little square that I'm drawing here is always perpendicular, that little square. Just for the sake of it, I want to talk about different ways in which math writers describe 90 degrees. Okay, let me see how many of you guys know here. Dylan?
Right triangle.
Right triangle, okay. Any others? Is it always a triangle? What else, Olivia? Tyler?
Yeah, right.
Right angle, okay. Any others? Is that a hand, Dylan?
I don't know, but all four sides are a square rectangle.
Yes, but what I'm saying is different words that they use, terminology that means 90 degrees. Is there another?
Is
Yes.
it complementary?
Complementary angles, okay. That means two angles that add up. Like if you have these two, this one and this one, they add up to 90. Those are complementary angles. Some people think complementary, oh, free food, Costco, complimentary. No, that's not what they're saying. Okay. What else? There's a few more that I want you guys to be aware of. We just talked about one of them. Perpendicular, right? So this means 90. And the example that Tyler gave us here, he said, well, base and height. Okay, when you look at a triangle like this, you're probably thinking triangle when you think of that, right? So this height is not one of the legs of the triangle. You guys see that? It's not this leg, it's not this, it's not this. It's straight down. It's called an altitude. The height of a triangle is called an altitude. Okay. I'm going to give you guys one more that I know you guys probably wouldn't have thought of. Tangent. Okay. You guys are like, what? Okay. So we'll do some drawing. This right here, if you guys are drawing this stuff, this is called an altitude. Okay. And then the other one is tangent, which looks like this. Here's a circle, here's a radius, and here's a line here. I will in a second. Hold on. So here's your radius. Here's a line that is tangent. Okay, so these are different terms here that all mean 90 degrees. And the reason why I'm introducing them is so you write them down, because I know you guys don't have perfect memory of things that you hear, okay? Very few people can memorize what they only hear or see, okay? But the reason why we want to remember these is because the writers of the questions will often write terms like two lines are tangent to each other, and you're like, wait, that sounds like something from trig. I haven't taken trig yet. How am I supposed to know that? Well, Eli told you that lines, when they're tangent to a radius, form a 90-degree angle. So that's what that is. Did everybody see these things that I have here? So that way you can remember. If they talk about altitude, you're like, wait, are we talking about flying? I'm talking about math, right? But they're not talking about flying. This is an altitude is the height inside of a triangle when you draw the line straight down for the height. Okay? These all mean 90 degrees. Okay? Complementary angles. That's complementary. These two, they add up to 90. Okay? Perpendicular. This is perpendicular up here. Okay. So a lot of vocabulary there. Parallel lines never intersect. I think you guys know what parallel lines are, right? Okay, you guys are good with that. And then list two right angles in the figure above. I think we already talked about that. So right angles. Let's turn this page. Let me see if you can do 2, 3, 1, 2, and 3 here on the next page. Let's try that.
Yeah, we usually since at the right angle a house, it has to equal 80, right?
90.
I mean 90, yeah.
Perpendicular means 90.
So we would be 90 minus 47. That's right.
All right, let's talk about these here. So for number 1, Omar, what did you get on this one?
43.
43. How did you do that?
Since it had to for the right angle, it had to equal 90. I did 90 minus 47.
Right, 90 minus 47, and you got 43. Good. All right. Tyler, did you get number 2? 20. Why 20? So this is 2 lines that are intersecting here. You've got an A and you got a 110 here. Dylan, what'd you get over here? You got B, which is 70. How'd you get 70? Or 110 from 180? So 110 subtracted, you get 70 here. Remember how we talked about supplementary angles? Supplementary angles add up to 180, kind of like a protractor, right? Protractor is 180, right? So if this is a protractor, 180, it's equal to 70 plus 110, right? So angle A is 70. Yeah. Question there, Dylan, or you want to answer the third one?
So, angle, I got number 3 for 90 because it's not talking about 47 story.
XYW is XYW. Okay, that's an interesting point there. But when they give you 3 letters, they're giving you a starting point, a middle point, and the ending. So this was X, Y, W.
Oh, no.
And they gave us 47 here.
I got it. I mixed the W. Yeah.
That's okay. Yeah. All right. Who wants to answer number 3 here? Tula.
I got C.
That's right. Tell us what you did.
I added 46 to 51, we got 97, and then subtracted 97 from 180.
You added the 46 and 51, and you subtract from 180. So you subtract 97, and you got 83, right? Good. So 83 is the right answer on that one. This was just, again, looking at a straight line and the three angles that made this protractor of 180. Do you guys see that? Straight line's 180. You could use 10 angles to make 180. Doesn't have to be 2. So they are supplementary there. Okay, we're going to move forward and talk a little bit about line segments here. And you'll often see these kind of questions on the test where they're giving you lengths and they want you to solve for a length. Let's go to this first one here. Let's have Dylan on this side read for us figure 5.
In figure 5, AG equals 35 and BD equals 21. If AB equals BC, what is the length of CB?
Okay. So who wants to take a stab at this one? Okay. Tula?
So, CG looks like it's about half its AB. So, would you do 35 minus 21, would you?
Let's do this first. Let's label. This is 35. Okay. And then the 21 was BD, which is here. Okay.
35 minus 21 is 14.
So this is 14
So
for,
that would be AB, and then CG looks like it's about half of AB.
I wouldn't use it based on what it appears to be. There's one more piece of information that they gave us that's very useful. Now that you found AB, Dylan, do you see it? What does it tell us?
AB equals BC.
AB equals BC. So this is 14 also. So rather than trusting what it looks like and saying it kind of looks like, that's too unsure, right? Now can you solve it? Yeah, 14 plus 14 is 28. And then this has to be 7 to add up to 35. Omar, did you have something similar?
Yeah, I got 83.
83.
Because I think I did this right, but I added the wrong thing.
The 35 and what?
Uh,
Are you looking at the same one we're looking at?
Yeah.
Okay. I don't know how it adds up to 83 though, does it? It says geometry line segments. I think you're on a different question. I think you're on a different question because there's no way it could add up to 83, no matter what you got here. These will not add up to it. I think you're on a different page. It's okay. But does everyone see how we got 14? 14, we subtracted 21 from 35, we got 14. They told us AB is equal to BC, so that's 14, and then the only thing left is 7. So the answer is 7. But that's more, it's a more confident answer than just what it appears to be. Does everyone see that? Okay, good. One thing I'm going to say at the bottom of this page, they said line segment is a piece of line and is named by endpoints A to B. That's what they're saying there. A midpoint is exactly in half. If you hear words like midpoint, it means that it divides it in two. If you hear the word bisect, it means it divides it in two. Okay, those are some geometry phrases there. Bisecting or midpoints. Okay, everyone try to do these 3 problems, 4, 5, and 6. So let's go over these. Let's start with number 4 here. And who wants to talk about number 4 first? Marcus, you want to tell us what you did here?
So I just showed what all the equals from G to F and 5. I did all of those.
So he labeled this.
Yeah.
It's a good thing to do. And then what else did you do?
E to G is 6.
Okay.
And F to G is 2.
Okay. And then how did you use the information here for E to F?
I did E to F. So I did E to G 6. So magically 2. Because F to G.
Right. You could have just used these 2 pieces of information and you get 4 right here. Like the D to F is not even necessary if you think about it. Not even necessary. Okay, good. How about number 5? Who wants to do number 5? Dylan, you want to tell us what you did here?
I basically just,
I'm sorry, say that again.
and the midpoint, I just kind of took out one.
You're like subtracting.
Yeah.
Okay, let me give you guys a faster method. Or Tula, do you have a faster method besides counting literally each notch? You go, I think I got this many on this side. I think I got the same number. What'd you do?
I counted from 1 to 7.
Right. It's 3. Okay, that's very good. What she did was she said from 1, that's why I didn't write the notches here on purpose. I did that because if you're counting notches, what if this was negative 100 and this is 700? Are you going to go 1, 2, 3, 4, 5, 6, and you're counting and you're counting and you're counting, like, oh, shoot, oh, man, I got to count over again. Negative 100, negative 99. Oh, shoot. Okay, don't do that, all right? So what Tula did here was she basically said from here to here is 8 units. How did she do that? She simply added them because this is 1 unit over below 0 and this is 7 units above 0. That's how she added them together. So if it's 8 divided by 2, then it's 4 units. Subtract 7 minus 4, you get 3. Or 4 plus negative 1 equals 3. So 3 is your answer on this one. Okay? 3 is the answer. So m equals 3. Okay, what about the last one? Tyler, you got the last one?
Use the midpoint of team B. So use the midpoint and it says TW, the whole thing is 12. And then it looks like the middle is the middle is B, so it has to be 6, and you divide it by 2. And then if you divide it 6 by 2 again, it's 3. That's what I thought.
So you wanted UV, right? So this turns out to be 3. That's correct. So yeah, the information that it tells you is that the midpoint, V is the midpoint of it. So the midpoint is equal to 6. And then they're saying that what is the length of UV? So if that's 6, then this is 3 there. That's what they have there. Anybody have different answers on that one? Yeah, good. You guys are doing pretty well with line segments. I don't think it's that bad. Let's move over to triangle. Is that a question there? Or are you? Okay, hold on a second here. Let's talk about triangles here. A few things that we want to establish, I think you guys know, is that with a triangle, it's 180 degrees inside. And there are certain types of special triangles like isosceles, equilateral, and right triangles that we're going to get into as we move forward with this. At the bottom of this page, they're kind of reiterating what I just said. 3 angles of a triangle add up to 180. They're talking about a right triangle, and they said that this line that goes diagonal is called a hypotenuse. Then there's isosceles, where there's 2 equal angles and 2 equal sides. Also, an equilateral has 3 equal angles. Also, it has 3 equal sides. That's all the bottom of the page. Everyone can see that, right? One thing I'm going to say about the equal sides on an isosceles and on an equilateral, I want to just show you real quick. For an isosceles, when they're talking about the sides, this side correlates to this angle down here. This side up here correlates to the angle down here. You guys know that? Okay, so in a triangle, it's always talking about an angle and its opposite side. So here's your equilateral. So it's the same thing where the angle is correlated to the side that is opposite to it. You guys learn that at school yet? Or that's an important thing to do, especially with right triangles here. Let me erase this one. So with a right triangle, we start with this hypotenuse. The hypotenuse is correlated to the 90-degree right angle. That's really important to know. This angle down here associates to this side over here, and this one over here associates to this side here. Okay, so that's important to know. So that's just something I wanted to drive home about triangles and how the angles are related to the sides. Okay, so for those pictures down there, you can draw those arrows if it helps you. Tula, you want to do figure 9 because that's what you had your hand up for earlier? Okay, and how do you know that it equals 60? Tell us how you got that. Right, but how did you know that it was going to be 60 times 3? Right, but then how did you know that it was equilateral? That's what I wanted to hear. So I know it's kind of loud, but what I'm going to reiterate what she said right here is because all three sides are 12s, we know that it's equilateral. And because it's equilateral, then all the angles are equal. So she said 180 divided by 3 equals 60. That's how she got the angle. And the value for A is equal to 60. So the answer there is 60. Everyone's cool with that, right? Okay. Real quick, the stuff in the middle, I'll go over this because I think it's also relevant here. It says, since all three sides of this triangle are equal, all angles must be equal. The angles of this triangle add up to 180. So we should fill this in. That's in the middle right there. And then there's a triangle that they draw for us. It actually has 3 triangles in one. Let me erase what I have here. Okay, so what would be the perimeter of this triangle, the overall triangle that we have here? What would you do, Tyler, for the perimeter of this one?
Add up the sides.
Add up the sides. So the perimeter of a triangle so add up the sides. Let's write that in there. Add up the sides. And for the one above that we see, what is the perimeter of the overall triangle? What is the perimeter of this triangle here? $40. That's right. I know it's hard to hear that thing there. So 40 is right. And then Omar, what's the area of a triangle? What's the formula for area of a triangle? Right, 1/2. So area of a triangle is 1/2 base times height. And if you were to calculate for this big triangle, how much was it? Because that's what they're asking. What is the area of this triangle here? You know the formula.
Is it the height on that side?
Which one? What? No. Remember we talked about this a few minutes ago. When Tyler was talking about height, I said that's called the altitude. Do you guys see an altitude here? So that's the height. This is a few minutes ago. We talked about altitude. Which one's the altitude, Dylan? It's 7. This is your altitude. Okay? So you have a 7 here. What's your base? Omar, finish this. 16. Okay? So you have your 1/2. Okay, finish this. What is the answer? Smaller. Dylan? 56, because 1/2 times 16 is 8. 8 times 7 is 56 here. Okay? Does everyone see that there? The key to this was the altitude was 7. That's your height, right? The altitude is 7. The 16 is the base. And we multiplied 1/2 times 16 first. That made it 8. 8 times 7 is 56. Okay? So that's our answer there. Okay? Let's continue. You guys all getting this stuff? This is stuff I feel like you guys should know, right? Okay, let's do these 3 problems, 7, 8, 9 on this page, on the following page. Should be pretty easy.
Equals 16. I did 5 plus 4, and
Yes.
that equaled 9. And then I said do 9 plus y equals 16.
Right?
And then I did 16 minus 9. 7.
That's right. So 7 is the right answer for Y. That's correct. Okay? Good job. All right. Luca, what'd you do for the next one?
For 8, I did, so testing what the value of A is,
Yes.
and we know that it's a right angle.
Okay, we have a right angle here.
So it's 90 degrees.
Right?
And if 30 on one side, on the other side, A will be 60.
Why 60?
because
This is the length of a leg, and they're looking for the length of a leg here. So I don't think so. Yes, over here, Tula.
it would be 30.
It'd be 30. Okay, is that what you got, Omar?
I got 15.
No, it's actually 30. Tell us why it's 30 here.
Because it's a type of triangle that has two equal.
Isosceles. Isosceles. How do we know this is isosceles, everyone? This is what? Okay, Olivia?
Because if this one is 90 and then there's 45, then there's another 90, 45.
This has got to be 45 down here, because if you took 90 away from 180, you got 90, divide that by 2, that's 45, 45, 90. This is called a special triangle, guys. This is called the right isosceles triangle, also known as a 45, 45, 90. When you have an isosceles triangle, remember me drawing those lines. This 45 is here, this one is here. If this is 30, this is 30 also. That's why I drew those lines. How many of you guys actually drew that when I did that? Okay, that's made for you guys for a reason. Yes, Tula?
Also, you could just equal the square.
You could, yeah, but I wanted to focus on this just so people recognize 45, 45, 90. It's a special triangle, okay? Last one here. Yeah, Dylan? Okay. That's a good way of putting it, yeah. And so your best answer is D. There's one thing I want you guys to remember here. This angle BCD that they're asking about is 150. This is called an exterior angle. An exterior angle is always equal to the opposite interior angles. These are interior angles that are opposite. They're always going to be equal to each other. So it's 150. So I'll write the rule here. Exterior angle equals the sum of opposite interior angles. That's a rule. Yes, Omar.
So that one I put 150, but then I changed it to E. Given by this ruler, since they gave us those two
80 and 70.
yeah,
This equals 30,
yeah.
right? So it works like a protractor, 30 plus 150. So it affirms it also that way. You could do that. If you didn't know this rule, you could add it up. 80 and 70 is 150 plus 30, that's 180 in here. But a straight line is 180. So 150 and 30. So this has to be 150 on the outside. Okay. All right, let's move forward. We're sort of racing against the clock, so I want to make sure we're covering a lot of stuff here today. This is talking about polygons. At the bottom of the page, just to reiterate things you may know already, it's saying that the perimeter is the distance around all of the sides of a polygon. A parallelogram has 4 sides in pairs of equal length. So that means the top and the bottom are equal. Look at that picture there. You can see it. Top and the bottom are equal. The slanted sides are equal to each other. The opposite angles are equal to each other. So you can see just visually 2 of them are acute angles, 2 of them are obtuse angles, right? So area of a parallelogram, who knows this formula here? Area of the, yes, Tyler?
Like base 1 plus base.
You're thinking trapezoid. You're thinking trapezoid, actually. That's just gonna, for this one, for parallelogram, which looks like this, you got your height and you got your base. Area of the parallelogram is just base times height here. That's it, okay? You're thinking of trapezoid, but trapezoid looks more like this. This is base 1, base 2, okay? But, and then that formula, since we're on it, might as well talk about, there's a height also. This is equal to area of base 1 plus base 2 divided by 2 times the height. Okay, but that's trapezoid here. Okay, that's trapezoid. This next one is rectangle, And who knows the formula for area of a rectangle? This should be something you guys have on your memory already. Tula? Length times width, so area of a rectangle. And then the last one is area of a square, which is the same thing. So area of a square, length width. Okay, so we should all have that down. Let's look at this first question here. Marcus, you want to read this about the satin ribbon?
Satin ribbon is used to trim the edges of rectangular quilt. The length of the quilt is 2 times width. If 15 feet of the ribbon are required to trim the quilt, what is the quilt's length in feet?
Okay, what would you do here?
So would the width be 15?
Hold on a second. Let's define these terms here. There's length and width, and how are they related to each other? Yes, they're all part of a rectangle, but here's your length. It says, in the second sentence, it says, the length of the quilt is 2 times the width. How do we translate that?
It's the length will equal 2W.
2W, right? So you got 2W here. Everyone see that? And then it says, if 15 feet of ribbon are required to trim the quilt, what is the quilt's length in feet? So what should we do here? 15 feet. Trim means to go around it. Okay, trim, I'll draw here so you guys can see. Here's your quilt. So it's saying a ribbon goes, a quilt could be like a blanket of some sort, right? So I just drew a rectangle here. A trim goes around the edge of it. So that this ribbon wraps around here, and it's 15, is it feet? Yeah, it's 15 feet that goes around the blanket. You guys see that? Okay, so everyone gets that now. So what formula do you think they're asking for? Olivia?
Couldn't you just like combine like terms because there's other 2 widths and there's 2 lengths, so it'll be 6W equals 15.
You're talking about which formula? So you can fill everybody in here because you're
So perimeter is 2L plus 2W.
That's what I'm glad you said that because people were not following what you were saying. Now what do you do with this here?
I guess you could translate it so it's just like 6W.
Right. Let's substitute.
2L is
Let's
4W.
substitute what we have here because Marcus gave us this. L is equal to 2W, so you go 2 times 2W plus 2W equals how much? You guys all see this? It says 15. The perimeter is 15.
6W.
I know. This equals 15. You guys all see this? So now this is 6W. This is 4, so this is 6W equals 15, right? All right? So now what is the quill's length in feet? So let's find the width, and then we can find the length. Okay? So how much is the width here? It's just 15. Well, don't even turn it into decimals. It's going to be painful. 15 over 6 equals W. Okay? Now take this W and put it in here. Okay? Since this is 15 over 6, put it in here. So this is L is equal to 2 times 15 over 6. What I was pausing on, Olivia, was if you go to decimals, it's just not going to be friendly. And you're going to go, I don't see decimals in the answer, so how do I do this? But when you multiply this, the 2 and the 6, they work with each other. This becomes a 3. So L is equal to 15 over 3. What's L equal to? 5. So that's our final answer. You guys all see that? So you don't have to divide it out and get these weird decimals. It's just not going to be friendly. The best answer is 5 here. Okay. So that was a little tricky because we had to know our formulas for perimeter. We had to know that we're dealing with perimeter, right? And then we had to substitute 2W for L, and then put it in there to find W, and then find L. So it's a lot of work there. Okay, let's try to do 10, 11, 12, and I think that's as far as we'll get today. 10, 11, and 12. All right, Omar, you want to tell us what you did with number 10?
Well, for number 10, it said that the area was 24.
Right,
And so I did what times 6 is 24.
right.
So I got 4, so the side must have been 4. And then I did 6 plus 6 plus 4 plus 1, I got 20.
That's right. So this should equal 20 here. That's correct. Good. All right. How about 11, Luca?
So for 11, it says that there are two squares within the rectangle,
Mm-hmm.
and they have sides of 1.
Okay, so you have 1 on each of these. Okay.
And then I should remember. What else was it?
You're almost there. You're almost
Well, I
there.
got 1 for my answer, but I feel like I'm having second thoughts right now.
Okay, it's going to be different there. If you think about it, you're now dealing with a triangle here. This triangle is just 1 and 2, right? So what's our formula for area of a triangle?
1/2 times 5.
Right, so here's what you have here. 1/2. The answer is 1. Isn't that what you had, Luca?
Oh, the answer is 1?
Yeah, because base is 2, height is 1, multiplied by 1/2 equals 1. You guys see the triangle here? Here's your height, here's your base. You see that? Base, height. So it equals 1. Last question before we take a break for the day. Yes. Tula.
I got 32.
32 for the last one. Let me erase all this stuff here. So what did you do first on this one?
It says that the width is 3 inches and the length is 5 inches, and this one is 8 twice.
Right. So it's going to be double. Dimensions are double. So,
Yeah, so I did 3 double is 6, and 5 double is 10. And then 10, 10, 11, and 6.
Right. So 32 is right. Does everybody see how she got that? Did everybody get different numbers here for perimeter? Okay, that's it for today, guys. We didn't get through all of it, but the homework is pages 82 to 85. I'm very confident that you guys are very strong with your geometry. Remember, no class on the 20th because Sacred Heart has an open house. I'm pretty sure some of you guys will end up going to that. And our final meeting is on the 27th. Okay? So the homework is 82 to 85. So 85. 82 to 85. You guys all see that? Okay, see you guys in 2 weeks. 2 weeks. Okay?
Thank you.
Okay.